Hello everyone, this is Shanku and welcome to part 4 of the Java interview series. In this video, I'm going to talk about some of the very important design patterns that are very frequently asked in interviews, and especially if you have more than 2 years of experience, then you can definitely expect to encounter a few of these questions in your interviews. So the first question is, how do you create an immutable class, or how do you make a class immutable? So let's create a new class and let's name this immutable. And let's have a few attributes inside this class. So I'm gonna say int age, string name, and let's have a map. I'm gonna say string say map equals new hash map, right? Let's get the imports. Yep. So while creating an immutable class, there are a few things we need to keep in mind. So the first thing is the class should be final, so that we should not be able to extend the class, or we should not be able to inherit the class. This class should not be extended by any other class. So that is the first thing. The next thing is all its attributes should be final and they should be private, so that they cannot be accessed from outside, accessed directly from outside. So let's just copy this. Final private, final private, final private. Okay, I'll just remove this. We should not initialize it directly like this. So how do we initialize these attributes? So for that, we're going to create a constructor, a parameterized constructor using all the fields, right? And since so int, we are already setting the age, and this is final, so this cannot be changed. And name also, string is a final class, or string is an immutable class. So once we set it, we cannot change it. But this map is mutable, right? So we should not be directly assigning the value of map. Here we should be doing a deep copy of all the objects that are present inside the map, right? So what we should be doing is create another map, and let's call it temp map, new hash map, right? And we should be just copying the elements of the input map into this particular map. So let's say map.entry string, say entry set in map.entry set, right? And then temp.put temp map dot put entry set dot get key and entry set dot get value, right? This way we can populate the temp map, and right, and this dot map equals temp map, right? So what we are doing is, instead of directly assigning the mutable object into this map, we are creating a deep clone of all the elements that are present inside the input parameter, the map, and then we are assigning that particular temp map to this attribute so that there is no direct reference of the objects that are present inside the map. Now, how do we get the objects, or how do we get the attributes in other classes, because these are private, right? So they won't be accessible to they won't be visible in other classes, right? So for that we'll be giving the setters. So it's a generate getters and setters, select getters. Okay, so again, well, returning the map, instead of returning, we are returning a direct reference to the mutable object. So this is again a caveat, and in a moment I'll show you how this can be a problem. So this is our immutable class. Right now let's test it if it is actually immutable or not. So I'll create a class called test, and inside this I would say immutable. So I'll just create an object of the immutable class that I've just created, right? Okay, first let's define a map. I'll say map string map equals new hash map right? And let's get the imports. Let's say map dot put, say ABC, value is ABC, sorry, right? And map dot put DEF, value is DEF, right? And let's set the age is 23, name as test name, and map as map, right? Now, okay, before that I'll just have the toString method here. So I just generate toString, right? And I just print IM, right? And what I'll do is I'd say im dot get map dot put, right? Say XYZ and XYZ, right? And I'll print IM again. Now let's see if our immutable class is indeed immutable or not. Run as Java application. So we can see our class is not immutable, not completely immutable, because we've been able to change this map. We've been able to add a new value to this map XYZ, right? So how do we make this completely immutable? So instead of returning a direct reference to the mutable object, what we do is we do the same thing that we did here. We create a temporary map, right? And then we return temp map, right? So instead of returning the direct object or returning the direct reference to the map, we are returning another map, right? Now let's run this. Okay, we can see this has not been changed. So now we can say that our class is immutable, and even if we are trying to put xyz into the map of this particular object of immutable class, we are not able to do that because our class is immutable, right? Okay, so the next question is what is a singleton class and how would you create a singleton class? So, and why do we need a singleton class in the first place? So basically singleton means there'd be only one object of the class in the memory, and there's already a playlist that I've created for design patterns, creational design patterns and other stuff. So I'll just put the link in the description below for detailed explanation of how to create a singleton class and what a singleton class is. You can just check out that video. And if you're asked to create a singleton class, how do you create a singleton class? So let's just delete this immutable class, delete all the contents of main, move the imports, and let's create a new class, right, and call it singleton. So how do you restrict or how do you prevent the creation of multiple objects of a singleton class or of this class that we're trying to create? So what we're going to do is, first we're going to say private static volatile singleton instance equals, all right, and what we're going to do is we're going to say private singleton so that we cannot use the constructor to create a new object of this class. So making the constructor private so that it is not accessible by other classes, right? And then we're going to provide a public method, public singleton, public static singleton, say get instance. So this is the only method, or this is the only way to get an instance of singleton class. And what we're going to do here is we're going to check if instance equals to null, right? We're going to say synchronized, and we're going to synchronize singleton dot class, right? And we're going to again check if instance equals to null, then instance equals new singleton, right? And then return instance. So how does this work? And let's try to understand each and every thing that we did to create this, make this class singleton. So first what we did is we created a private static volatile variable of the type singleton. And why static? So that we don't need to create an object of the class, to call this method. So this is being called in a static inside a static method, right? This instance is being used inside a static method. So to be able to access this static and this variable inside a static method, we need to define this as static as well, because static inside static methods only static attributes can be called, but inside non-static methods static attributes can be called as well, right? So, and again, what does this volatile mean? So volatile is used in the case of, you know, having multiple threads. So when we have multiple threads trying to, you know, access this code, what threads do is they store the values of the variables, or they store the values of the attributes in the thread cache, which is essentially a stack, right, that is associated with each thread. And when we say that this should be volatile, that means every time the thread tries to, you know, fetch the value of this attribute, it would always fetch it from the main memory, from the heap. It wouldn't fetch it from the thread cache, from the cache that is that it has, right? So every time it fetches the value of this particular variable, it will always fetch from the main memory, or from the cache, from the heap memory, right? And then we are setting the constructor as private, so that we cannot create an object using the new keyword, or using by calling the constructor of this class inside another class, right? And then we have this method which provides us, or which returns this singleton type, right? And it is used to create an object of singleton. Now inside this we have two if conditions. If instance equals to null, then we are synchronizing and again checking if instance equals to null. So why do we have this if condition written two times? Now why do we have the outer if? Because when we go inside the synchronized block, it will put a lock, right, on the class. So this is a class level lock, this is not an object level lock. So no matter how many objects we create of this class, all the threads are going to share, you know, all the threads are going to wait, and this particular block can be executed by only one thread at a time, no matter how many objects of this class we have, and no matter how which object a particular thread is using, right? So if we don't have this check, if we don't have this null check, then every time a thread comes to this part of the code, it will always put a lock, even if there is already an instance present for singleton class. So to prevent that unnecessary locking of the singleton class, we have put this if condition. So only if the instance is null, then we'll put a lock. If the instance is not null, if there's already an instance, then we'll just not put a lock, right? And if there's if the instance is null, then we are synchronizing, or we are putting a lock on the class, singleton class, right? And then we are again checking if instance is null. This is because inside, so there'll be only one right, there'll be only one thread that gets access to this particular piece of code at a time, right? And comes here, suppose we don't have this if statement, and there's another thread that comes here, and then it is again put to, you know, put to the waiting state. The first thread is put to the waiting state, and then the second thread that was also present here creates this instance, and then again the first state, which was to the waiting state, so it has already checked the value, right? Here it has already checked the value is null, and it has entered into this block. Now it won't again check if this was not there. It won't again check the value of instance. So the first thread has already created an instance which the second thread won't get to know, so it will again create another instance. So to prevent that, we have put this if check here, right? So this is how we can create a thread set singleton, right? And apart from this, you should also, if you have an experience of 2 years or more, then you should definitely know about factory pattern. a few of the other creational patterns, such as factory pattern, abstract factory pattern, builder pattern, and then you have other types of design patterns like producer consumer design pattern. So these are some very important topics, or the decorator pattern. So these are very important design patterns that you need to know about. And if you are interested in checking out my videos where I talk about these kind of design patterns, you can check out the playlists for the same, and I'll put the link in the description box below. And you should also know about the MVC design pattern, the DAO design pattern, the front controller design pattern, which most of us have worked with. So yeah, those are the important design patterns that we need to know about and prepare ourselves before appearing for a Java interview. So that is all for this video. If you like this video, please give it a thumbs up and stay tuned for part 5. Thank you.